All right, so we're looking at rigid transformations in this video. It's probably a good idea to have a piece of graph paper. To transform something means that we're going to change it. But rigid means that it's not flexible, it's unbending, so to speak. So we're changing it, but it's not going to change. So we're going to end up moving it about in the coordinate plane. A rigid transformation is a transformation that produces congruent images. So the size and shape stay the same. We're just going to move it around the coordinate plane, but we're not enlarging it or shrinking it or distorting it in any way if it's rigid. The original shape is called the pre-image. It comes first. And the new shape is called the image. So there's our vocabulary, and I'm going to use these graphs to just kind of explore, and we're going to discover the rules for these different types of transformation. But there are three rigid transformations. There are three of them. They're translations, reflections, and rotations. Those are the three rigids. Okay, starting with the translation. So I'm going to go ahead and graph a figure in the coordinate plane, but I'm going to do it so that I can move it around. Let's just do a segment. So we'll put A here and B up here. So we have segment AB. And what if I take it and I slide it? Let's just write what we're going to do. Let's slide it right 5 and down 4. Where will the new image end up? So this is the pre-image. It comes first. If we take this, and I'll literally do that. So I'm going to trace it. Here's AB. And let's just drag B. So I'm going to go to the right 1, 2, 3, 4, 5. Notice A comes along, and then we're going to go down 4. 1, 2, 3, 4. If we do that, B ends up on the x-axis and A is down here. We moved it right and down. Notice that it's running in the same direction and the size is exactly the same. So let me go ahead and plot where those points ended up. So B was here and A was here. Now, if I draw it like that, you wouldn't have any idea which one came first. The image, we put a prime marking on it. This is the image because of the prime, and this is the pre-image. You could tell that looking at anyone's graph because of the marking. But what I want to look at specifically is what happened with the ordered pairs. So A was over here at -3, +1, and B was at -1, +4. The new B is sitting here at 4, 0, and A is at 2, -3. Could we get from this ordered pair to that one without having a piece of graph paper? Well, how do I go from -1 to +4? I add 5. And how do I go from +4 down to 0? Going down 4, I subtract 4. So I added 5 to the x-coordinate and subtracted 4 from the y-coordinate. Does that work here? If we start with -3 and add 5, we surely do get positive 2. And positive 1 minus 4 would put me at negative 3. So there's an ordered pair rule that we used here. For this example, we took our original ordered pairs on our pre-image, and what did we do to the x-coordinate? We added 5, and to the y-coordinate, we subtracted 4. That's what translation rules look like, pre-image and image. So if you have a translation, what happens to the original ordered pairs on the pre-image? Well, you're always going to the x value, you're going to add or subtract some number, let's just call it h, and to the y value, you'll add or subtract some number in order to produce the new image. That's what our translation rule looks like.